In this tutorial, we will be discussing different units of concentration, specifically molarity. In a dilute solution, it contains small amounts of a solute to relative of the amounts of the solvent. In a concentrated solution, it contains larger quantity of solute in comparison to the solvent. There are several different ways of measuring concentration. Molarity, which is what we will be talking about this time, molality, parts by mass, parts by volume, mole fraction, and mole percent. Molarity is the amount of solute in moles, specifically, divided by the volume of the solution, which, remember, the solution is the solute and the solvent added together in liters. So molarity is the moles of the solute over the liters of solution. In order to create a molar solution, first thing you need to do is figure out what your concentration you want and how many grams of moles you'll need for that concentration. So for instance here, we decided that we needed to make a 1 molar solution of NaCl. So that means we need 1 mole of NaCl for every 1 liter of solution. So first thing you're going to want to do is figure out how many grams of NaCl are in 1 mole of NaCl. You do that by looking at the molar mass, which is 58.44 grams. You add that to, this is called a volumetric flask. Notice that there's a little mark here. That mark indicates 1 liter. Now there's different volumes of volumetric flasks. It could be 500 milliliters, it could be 2 liters. You need to figure out the molarity of what you're going to be adding in there, the volume of what you're going to be adding in there, before determining the grams. This 1 liter mark is extremely specific. It's measured, depending on the company, up to like 0.0001 accuracy. That means that when you add the water to it, once you've hit that line, you have an extremely accurate solution of molarity. Notice we put the particles in the first, and then we're adding water, because remember, it's the solute and the solvent added together. So here's the solute. Now we're going to add the solvent until it reaches that 1 liter mark. So how do you solve for molarity? Let's do one practice. Calculate the molarity of 25 grams of KBr dissolved in 750 milliliters. Molarity is moles of the solute, so moles of KBr, over the volume in liters of the solution. We have 750 milliliters for the solution. We have 25 grams for the KBr. We need to convert that to moles before we can use it in the calculation. So 25.0 grams over 1. We have grams on the top, which means we want to put grams on the bottom. Look at the molar mass. It comes out to be 119.0 grams in every mole. We got that by looking at K. We have 1K, which is 39.098, and 1 BR, 79.904, and we added those together. Divide that out, and that comes out to be 0.21 moles. Now to find the molarity, it's going to be 0.21 moles over the liters of solution. It gave it to us in milliliters. That means we need to convert this to liters before we go on. Divide it by 1,000 to get it into liters. I know some people are used to just moving the decimal, but I like to write it out just in case somebody is unaware of how we got that number. So 0.21 divided by 0.75, and the molarity comes out to be 0.28, and you abbreviate that with a big M.